Okay, so we're going to talk about something called Pascal's triangle, which is kind of an easy way that we can multiply a polynomial by itself multiple times. So previously, when we were multiplying polynomials, you had like two very different polynomials. They each had different parts to it, and we had to use like the distributive property, or we talked about that box method when it came to multiplying them. Pascal's triangle is used when you're taking the same quantity times itself numerous times. So like in the past, we've maybe seen something like y plus 5. So I've written something like this, y plus 5 squared. Okay, which in the past we knew that as y plus 5 times y plus 5. Okay, because it's the same quantity twice. You're squaring it. So what we're going to do is, what happens if I take it to the third power, or to the fourth power, or to the fifth power? So that exponent tells you how many pieces you have. But if I had this y to the fifth power, then it would be 5 of them in a row. And to multiply that, it can become very complicated very fast, because you've got a lot of pieces that you're trying to multiply together. Now you can use the methods that we've been talking about, like your distributive property. What you'd have to do is almost take those 5 quantities and start pairing them up. Like take the first 2 and distribute those. Take the second 2 and distribute those, and then attach that last one. Then you'd have to do another set of distributing. And then you'd end up doing that as many times as needed until you actually multiplied everything. But like I said, that can become really confusing, time consuming. Okay, there's not the shortest method to do that. And that's why we have something called Pascal's triangle. This actually makes this process a little bit quicker for you. So we use this to help us expand binomials, and each number in Pascal's triangle is the sum of the two numbers diagonally above it. Okay, so let me show you what I mean here. If I'm looking at these numbers here, if you guys can see where I'm circling, like the 1, the 2 below it. If I add 1 and 1, I get 2. Okay, so the 2 together underneath it is going to get, like if you add those, is going to get you your next number. And this works for the entire triangle. So like if I come down to this 1 and this 3, 1 plus 3 is 4. Okay, 15 plus 6 equals 21. So all of those numbers are going to do that pattern. So when you guys are using Pascal's triangle, you don't need to know this entire thing. Okay, you definitely don't need to like memorize this entire triangle. But what you should be able to do is actually construct it if you knew that those two numbers together will get you the number right underneath it if you add them. These are broken into what we call rows. Okay, so the very first one, the one at the very top, this is called row 0. Okay, that's when you take anything raised to the first power. It's just going to be itself. It's not going to change that number or that quantity at all. After that, so the first 2 rows that are, or the ones that are side by side, that's going to be called row 1. And then keep going down, you get row 2, row 3, and so on. Okay, and I could keep going. I could keep labeling them. But know that Pascal's triangle does not just stop where I have it stopped up here. It keeps growing. And it could keep growing forever and ever. Now the chances of us kind of going beyond even row 6 or row 7 are not super likely. Most of the time when you're doing a problem like this, you're going to deal with an exponent of like a 3, a 4, a 5, something like that. What we use this for is those numbers up there represent the coefficients when you expand a binomial. So when you're taking a quantity times itself numerous times, and you're trying to figure out what numbers go in front of your terms, like what goes in front of the x to the 4th or x to the 3rd, these numbers up here, and depending on which row you're in, are going to be the numbers that you look at. So if you're raising something to the 5th power, you're going to look at the 5th row, which would be this one right here. So the numbers that you would use would be 1, 5, 10, 10, 5, 1. Those would be the coefficients that you would grab. Okay, if I was looking at something raised to the third power, I would use row 3. So my coefficients would be 1, 3, 3, 1. Okay, so you'll get to know this fairly quickly because you'll be using it a lot in this section and as we practice. But whatever you're raising it to tells you which row you use. So if you're raising it to the fourth power, you use row 4. If you're raising it to the second power, you use row 2. Okay, so let's do an example so you can actually see how this works. The first one I have is that we're taking x plus y to the 5th power. Okay, so remember, this means that I would be taking x plus y times itself 5 times if I actually expanded that out. Okay, and I kind of talked about this earlier. If I was going to try to do this using the distributive property, I'd have to almost pair these off, like pair these first two together, pair the second two together, distribute, or like use your FOIL method on those, and then you'd get another set of quantities. You'd have to multiply those together, and then you still have that x plus y on the end. So instead of doing that, I'm going to use Pascal's triangle. Now, since I have it raised to the 5th power, that means that I need to use row 5. Okay, row 5's coefficient. So if I go back up to my triangle here, row 5 is this one that I had highlighted when I was talking about this. You're going to use the 1, 5, 10, 10, 5, 1. So what I do is I just write down those numbers here. 1, 5, 10, 10, 5, 1. So what we do is we take our terms, our x and our y, and we start with x being the biggest exponent first, and it's going to have a 5 because we have this raised to the 5th power. So there's going to be an x to the 5th in here somewhere, just like there's going to be a y to the 5th in here somewhere too. So we're going to have the 1 is the first coefficient. That's the one that sits in front of the numbers. So I'm going to start with x to the 5th and no y. So it's just going to be x to the 5th. Now for the second term, it's 5 is my coefficient, so I'm going to do plus 5. And this is where your letters start to change a little bit. So instead of having x to the 5th again, we actually go down 1 on the x, so it goes x to the 4th. And now we're going to start seeing our y's show up. And so this first one is just going to have a y. No exponent with that. So then we're going to keep this pattern where I'm going to keep writing the numbers. So like this next one is plus 10. I'm going to take my x, I'm going to drop it one more time, its exponent. So now it's going down to x to the 3rd. And I'm going to increase my y by 1. So it's going to say y squared. And I'm going to keep doing that until I get to the very last number. So the next one's going to say plus 10. X is going to drop down to x squared. Y is going to go up to y to the 3rd. The next coefficient I had is a 5, so plus 5. X squared is going to go down to just x. Y is going to go up one more to y to the 4th. Now I have plus 1. So plus, I don't have to write the 1 in the front. Now x on the previous term already only had x, so if I get rid of it, it's gone. And so there's going to be no x on this last term. But y to the 4th can go up one more, and that's how we get our y to the 5th term. And so this is the expanded form. All of them are going to have this pattern with those exponents on those letters. And the letters can change. They don't have to be x's and y's. They could be a's and b's. They could be m's and n's, whatever. But whatever that beginning exponent is, like what you're raising it to. So in this case, it was the 5th power. You always start with your first letter to the 5th power, and then that letter works its way down, one at a time, until it's gone. The other letter, we almost start backwards with it. Like y to the 5th started at the end, and then it worked its way down going to the left. So once you see that pattern, and it's going to be like that for all of these, that they're going to have that pattern where one letter decreases as it goes to the right, and the other one increases as it goes to the left. They're going to kind of cross paths somewhere in the middle. So we're going to keep practicing and do a couple more here, but we're also going to talk about like what happens if you have more than just x and y, if you start having numbers and that kind of thing added into it. So each piece in your expanded form is going to be made up of 3 parts. So each term has 3 parts to it. The first part is your coefficient. So that row of numbers that we pulled, that's piece number 1. So whether it was a 1, a 5, a 10 on the last one. Step 2 is the power of your x term. Now I have x in quotations because x isn't always going to be there. It could be an a instead. It could be a 5. It could be a combination of letters. It doesn't have to be x. It could be whatever they wanted it to be. But that's the one that decreases by 1 as we go throughout the problem. So as you move through the terms, that exponent starts at the highest and then it works its way down. The third piece, or the third part to your term, is the power of y. Again, y is in quotations because it could change. And that one increases by 1 in every single term. Note that the first term is always raised to the power, so that biggest exponent. That's that 5 that I had highlighted on the last one. This one has n because this could be talking about any case. It doesn't always have to be raised to the 5th power. It could be raised to the 4th power instead. And so that's going to always attach to the first term and to the last term. And that's kind of how we use those to kind of help us with our patterns. So I'm going to show you how I break these apart for all my problems so that you guys have a way of like always following these, so that no matter what the terms are that they give you, whether it's an x plus y or it's a letter and a number, or if there's a number in front of your letter, you know how to handle this type of problem. Okay? So what I'm going to do is I always first figure out what am I raising this to? What's my power? So this first one is x plus 2 to the 5th power. Remember, that tells you what row you use. So 5th power means we're using the 5th row. So we're using the same coefficients that we did on that last problem. So I'm going to write those across the top. So I'm going to say for Pascal's triangle, I'm going to be using the numbers 1, 5, 10, 10, 5, and 1. And make sure you give yourself plenty of space. Now look at your 2 terms. Okay, so I'm going to come back in a little bit here. We've got x plus 2. This is like up here, those x and y's that I put in quotation marks, because those are the terms that are changing for your problems. So in this situation, we're going to be talking about the power of my x, and then we're going to talk about the power of my 2. Those are the other 2 parts. Okay, remember Pascal's triangle, the coefficient became part 1. So parts 2 and 3 are going to be the x and the 2. So right underneath it here, underneath where it says Pascal's triangle, I always write power. For this one, it's going to be x. And then for the last piece, it's going to be power of your 2. Okay. So I start with x. I always just go to the second row. X, because it's all by itself, you're going to start with x to the 5th power. And you're going to work your way down with the exponent 1 at a time. So you're going to take 5 minus 1 to get the next one, which is x to the 4th. That goes underneath the 5. Underneath the 10 then, you should have x to the 3rd. The second 10 should say x squared, and then you have x. The 1 is not going to have an x. That last 1 is not going to have an x attached to it. So if you don't like the whole, because some students don't like that there's a missing piece there, just put a 1. If you don't like the missing whole, just put a 1 there. It doesn't matter because anything times 1 is not going to change the problem. So that's why I said you can use a 1. Now, 2 is the second piece. So what I do, instead of starting at the front, I actually start at the end because I know at the end I'm going to have it raised to the 5th power. So underneath this last one, that's where that hole was at for the x. I'm going to go down to my 3rd row here and I'm going to write 2 to the 5th power. Now I'm going to work my way to the left and I'm going to be decreasing my exponents just like I did with the x's. So going to the left one, it's going to say 2 to the 4th. Then it's going to say 2 to the 3rd. 2 squared, and then a 2. And again, there's a hole because that first term should not have a 2 attached to it. If you don't like the hole, again, you can put a 1 there if you want to make sure that they all get spaced and they all have a piece. Okay, so what I do here then is I circle the columns. After I've circled them, I have to multiply the pieces that are in the column to get my final term, because I'm trying to simplify it here. So 1 times x to the 5th is just going to be x to the 5th. This next term here, I have a 5 times x to the 4th times 2. So 5 times the 2 is going to be 10, and then x to the 4th. The next one, you're going to take 10 times x to the 3rd times 2 squared. So take your numbers 10 and 2 squared. 2 squared would be 4. So you're taking 10 times 4, which would be 40. And then you have x to the 3rd. For the next one here, what's 2 to the 3rd? Anybody know? 2 times 2 times 2? 8. So we have 8 times 10, which would be 80. And then you have x squared. 2 to the 4th power. 2 times 2 times 2 times 2. Okay, that's going to be 16. 16 times 5 is also 80. So plus 80x. And then the last thing is to take 1 times 2 to the 5th. 2 to the 5th power is 32. And then times 1 is still going to leave it 32. And this is your answer right here. Okay, so when I'm using Pascal's triangle, this is what I always do. I write out my coefficients. I write out my first terms, whether it's an x or whatever letter, and then I write out my second one. And I kind of just follow that same pattern there. Okay, let's go on to the second one on that same page. Second one here says 2x plus 3. That whole quantity is raised to the 3rd power. So this one's going to be a little bit smaller because it's raised to the 3rd. It's not raised to the 5th. So 3rd means that we use the 3rd row. So row 3. Okay, so let's go back up to our Pascal's triangle. Back up here, row 3 is the other one that I had highlighted from earlier. So those numbers are 1, 3, 3, 1. Now my first term here, it's not just x, it's 2x. Okay, so I'm going to have to do the power of the 2x. And then the second piece is that 3, so I'm going to do power of 3. Now, for these ones, you will want to be careful when you're writing out the 2x, because it's not just x that's being raised to a power like the one before had. Like the last one was just x plus 2, so we would just take x to the 5th, x to the 4th, x to the 3rd, and so on. This one, you have 2x. That whole quantity has to get raised to the power. So I'm going to start again with 2x, and it's going to be raised to the 3rd power. But what I do to make sure that I don't forget that it goes to everything is I put 2x in parentheses and then raise it to the 3rd power. That kind of tells myself I have to do x to the 3rd, but I also have to do 2 to the 3rd. I have to make sure I do both of them to the 3rd power. Then I'm going to do 2x, again in parentheses, squared. And then this last one is just going to be 2x. Now, I don't need to write a 1. You can if you want to, but it's not really going to affect it at all. And then again, remember that last one is going to have the whole there. Okay, starting with 3 then, I start at the very end. And I put 3 to the 3rd. Now this one's just a number, so I don't have to worry about doing parentheses or anything different. And then I just work my way back to the left. So the next one says 3 squared, and then 3. Okay, I still circle my columns here. and then I multiply those terms in those columns. Now make sure, like I said, with these pieces in parentheses that you're doing the number and the letter to that exponent. So for this first one you have to do 2 to the third, which is 8, and then x to the third. So that first one is actually going to be 8x to the third, not 2x to the third. You got to do the 2 to the third power as well. Okay, next one. Let's do the 2 squared first. What's 2 squared? 4. Okay, so what's 4 times 3? 12. We have another 3. So 12 times another 3 is going to get us up to 36. So this next term is going to say plus 36, and then it's going to have x squared. Next one, you have 3 times 2 times 3 squared. Let's start with 3 squared. What's that? 9. What's 9 times... let's do 9 times 3. What's 9 times 3? 27. What's 27 times 2? Close. 54. And then you're going to have x. Last is 3 to the third power. 3 times 3 times 3, which is going to be 27. And that's your answer there. Don't be afraid on some of those. Raise to the powers, grab a calculator to help assist you with that math. Okay, especially if they start throwing big numbers in there like 5s. Okay, if you've got like 5 to the third power, that already is a big number. And then if you happen to start taking it times like a 2 or whatever, it just gets bigger. So use a calculator to help you guys if you need to. So on the next page, there are 2 examples like I just showed you guys. There's this one that says y minus 4 to the 4th power. And then underneath it is this one. It says 2x plus 3y to the 4th power. I'm going to give you guys a couple of minutes to try to do both of them. And then we'll come back together here in just a couple minutes. I'm going to give you guys a good chunk of time. And we'll come back and talk about what they should have looked like. Okay, coming back up to this first one. You're using row 4, so your coefficient should have been 1, 4, 6, 4, 1. Power of y looks pretty standard, y to the 4th, y to the 3rd, y squared, and y. Now because this one has a minus sign, you have to make sure that you take the minus with the 4, so it's actually power of the negative 4. So if you forgot to grab the negative 4, it's not going to really change your numbers, but it's going to change the sign of some of your terms. Okay, so after I got these lined up, I do my rows. Or not my rows, my columns. Okay, so the first one should say y to the 4th. Then this one you have 4 times negative 4. So again, if you didn't pull the negative, you should have still gotten 16. But you have to have that negative there, so this should say minus 16 y to the 3rd. So if you have plus 16, make sure you change it to a minus sign, because the sign does matter there. You want to make sure that you watch that with the minus signs there. Now this next one, negative 4 squared, that's going to become positive 16. Times 6 is going to bring us up to 96. So plus 96y squared. Then we should have minus 256y. And then plus 256. Notice on those that the signs just seem to alternate. Minus, plus, minus, plus. So that pattern's going to happen on these types of problems where you have a minus sign in the problem there. It's just going to change. It's going to alternate those signs between a plus and a minus sign. Okay, so this should have been your answer. Now, for the last one, this one, you don't have to worry about any negative signs, but the pieces are a little bit more complicated because you've got a 2x and you've got a 3y. So that's the case where I put them in parentheses so that I make sure when I raise it to the power, I do that to the number and to the letter. Okay, so I'm going to do my columns here again, circle those up. So the first one should have said 16 x to the 4th. Next should say plus 96 x to the 3rd y. Next one says 216 x squared y squared. Plus, next one is also 216, should be xy to the 3rd. And then the last term should be 81 y to the 4th.